x minus 1 squared over 4. Because basically I can rewrite this as that to the n, right? And so it's a nothing with n's in it to the n power, right? So basically when you see it like this, yep, I'm right. When n is 1, I get this, and n is 2, I get this times itself, right? And n is 3, I get this times itself. So what am I doing? I'm simply multiplying by this over and over again, right? By x minus 1 squared over 4, all right? And those of you that did the ratio test on this, did you end up getting x minus 1 squared over 4 as your L value?
Yeah.
Yes. Okay. So again, you would have been fine with the first part, right? Find the interval of convergence, right? Because you have the same value that you're making less than 1, right? As the geometric, okay? So this is going to converge when the absolute value of x minus 1 squared over 4 is less than 1. Now technically in this case I really don't need the absolute value per se, although I can handle a little bit. So my first move would be to multiply by 4, then square root it, so you really get the absolute value of x minus 1 is less than 2. Right, so therefore it's centered at
1.
Radius of
2.
2, so 1 plus 2,
3.
1 minus 2.
-1.
Okay, so your interval is from -1 to 3. Okay. Check it really quick, right? My endpoints should give me kind of that ratio of 1, right, from a geometric, right? Okay. And so, -1, -1, -2 squared is 4, 4 over 4 is 1, right? Perfect, that's working. 3 minus 1 is 2, 2 squared is 4, over 4 is 1, right? Okay, and so again, if you went back, right, if you went back and put 3 in here, you'd get 4 to the n over 4 to the n, which is 1, right? So your series is 1, and the limit as n goes to infinity of 1 is not 0. It's 1, right? So therefore, at 1, if I didn't recognize this as geometric, right? If I recognize the geometric, I'm done. Right? It never is inclusive, never. Right? Geometrics only converge when the absolute value of r is less than 1, and they diverge everywhere else. Okay? But if I did the ratio test on it, I have to go back and check 1 or -1 and 3. At 3, I get the same series. Right, so I just get 1. At -1, right, back into here, I get -2 to the 2n, right? But that's really squaring that, so I get really 4 to the n over 4 to the n again, so I get 1 again, which again diverges. Yeah, 4 to the n over 4 to the n is 1, and the limit as n goes to infinity of 1 is not 0, therefore it diverges by the nth term test. Your series would be 1 plus 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 1. Right? That's going to sum to an infinite number. Right? Again, that's why we don't have anything inclusive, which we should have known we're not going to include anything because we should have recognized it as geometric. Okay. All right, so now what does it sum to? Okay, so I got to find my first term, which is when n is 0. Okay, very careful. Find your first term. It's not that hard. Do the math. Okay, put 0 in for n. This is x minus 1 to the
0,
which is
1,
over 4 to the 0, which is
1,
and 1 divided by 1 is
1.
1. See, wasn't that hard? No, that's my first term. Okay. But again, what I want you to do is make sure you find the first term. Some of you will want to get into, well, the first term is just that, something in here, right? And you might make a mistake because a lot of the time it depends on if n is 1 or 0, right? And then that causes, so if you get into this sort of robot mode potentially, oh, I just grabbed this term here or whatever it is, or it's always 1 or something like that. No, right? So just take the few seconds to put the first value in. Get it. So it sums to 1 over 1 minus x minus 1 squared over 4. Alright? So first term, 1 over 1 minus your common ratio. Common ratio was our x minus 1 squared all over 4. Okay? Now simplify this because this is a little bit ugly. Let's get rid of the 4 in the denominator by multiplying by 4 over 4 is a great move for it. Okay, so take that down here. I get 4 over 4 minus x minus 1 squared, right? Maybe that's okay. The other thing I could do is expand that and distribute the negative through to clean it up a little bit more. So this is going to be 4 over 4 minus x squared minus 2x plus 1. Again, that should be an automatic x minus 1 squared. Right? Square the first, square the last, multiply the 2 together, double it. Right? That should be in your sleep math at this point in time. So I get 4 over 4 minus 1 is 3 minus x squared plus 2x. Something along those lines. No, my first term is 1. Geometric sum to first term over 1 minus your common ratio. So our first term is 1. Yeah, geometric sum to. The sum of a geometric is the first term over 1 minus r. That's a formula. The sum of a geometric. Yep. So this series for any x between negative 1 and 3, not inclusive, right? This series would sum to whatever value I get from here. Okay, so again, that's the idea with it. Okay, so again, if I put in 1, right? Right, so if I put 1 in here and did the math, right, I would get what that sums to. Alright. So second one, again, hopefully now we see it as geometric, okay? So it's going to converge when the absolute value of r is less than 1. What's r in this case? Natural log of x. This is going to converge when the absolute value of natural log of x is less than 1. Now this one, unfortunately, I can't write as x minus a is less than r, right? I can't get this into that form. Okay, so I'm going to have to just solve an inequality. All right. Not that big of a deal. Again, absolute value either spits out itself or it spits out the opposite of itself, right? So either natural log of x is less than 1, or the natural log of x, the opposite of that, is less than 1, right? So that's how I solve inequality, or how I solve absolute values, right? It's either itself or it's the opposite of itself. Okay, solve, what do I do here? E, right? So x is less than e to the first, or just e. What do I do first here? Divide by negative 1. So this becomes the natural log of x is greater than negative 1. Again, exponentiated. This becomes x is greater than 1 over e. E to the negative first is fine. That's equivalent to 1 over e as well, though. Right? So my interval is from 1 over e to e, right? Alright. Which makes sense when you think about the graph of natural log, which again we've talked about a ton. Right? Here's the graph of natural log, right? That is the function that I'm multiplying over and over again by, right? Natural log of x times natural log of x times natural log of x times natural log of x. Okay? again, for it to converge, I need to be in this small little window here, right, where my values of natural log are between 1 and negative 1. Okay? So what x value gets me to 1? E. What x value gets me to negative 1? 1 over e. Right? So 1 over e is, whatever this x value would be right there. Okay? And again, here's a case to be very careful. Make sure you do your math, right? Because it's pretty easy to go, oh, it's going to be e or negative e or something like that, right? Because you're just not thinking, right? You're just like, oh, I got e for this side, and it just kind of always seems, so it's negative e on that side. No, right? It's not it at all. Okay, so again, just do your math. Okay, again, x first off, and then if you're clearly not thinking, x can't be a negative number because you can't take the log of a negative number, right?